Good day everyone. This time, we are going to add or get the sum of the first n terms in a geometric sequence. Let a sub 1 be the first term, r the common ratio, n is the number of terms, and a sub n will be the nth term. The sum of the first n terms in a geometric sequence is obtained by a sub 1 times 1 minus r raised to n all over 1 minus r, where r is not equal to 1. Let us find the sum of the first 10 terms of a geometric sequence 2, 4, 8, 16. The common ratio is obtained by dividing 4 by 2, and that is equal to 2. Since the common ratio is not equal to 1, we may use the formula S sub n is equal to a sub 1 times 1 minus r raised to n divided by 1 minus r. So we are going to look for the sum of the first 10 terms, or S sub 10, given that n is equal to 10 and a sub 1 is equal to 2. All you have to do is to substitute the corresponding value of the variables to the equation. So we have S sub 10 is equal to 2, that is the first term, times 1 minus r, which is 2, raised to 10, and that is the value of n, divided by 1 minus r, which is 2. So 2 raised to 10 is 1024, and 1 minus 1024 is negative 1023, multiplied by 2, that is equal to negative 2046 divided by negative 1. So the sum of the first 10 terms of the geometric sequence 2, 4, 8, 16 is 2046. But what if r is equal to 1? From the given equation, we cannot use 1 since it will give us an undefined answer. Let's have an example. Find the sum of the first 6 terms of a geometric sequence 3, 3, 3, 3, 3. We cannot use this equation since r is equal to 1. But instead, all you have to do is to add all those terms or simply multiply the value of a sub 1 by the number of terms, which is 6. So 3 times 6 will give us the sum of the first 6 terms of the sequence, which is equal to 18. Therefore, if r is equal to 1, the sum of the first n terms of a geometric sequence is equal to the product of the number of terms and the first term. If r is equal to negative 1, there are two conditions. First, let's have this example. Find the sum of the first 6 terms of a geometric sequence 3, negative 3, 3, negative 3. If we are to add these numbers, S sub 6 is equal to 3 plus negative 3 plus 3 plus negative 3 plus 3 plus negative 3. As you can see, these numbers are in pair and will give us a sum which is equal to 0. Therefore, if r is equal to negative 1 and n is even, like what we have here in this example, S sub n will always be equal to 0. This time, let's have this example. Find the sum of the first 7 terms of a geometric sequence 3, -3, 3, -3, and so on. As you can see, the value of n here is an odd number. So, the sum of the first 7 terms will give us this equation. Observe that we have also pairs from this equation, which will give us a sum of 0. Therefore, the sum of the first 7 terms of this geometric sequence is equal to 3, which is actually the value of the first term. Therefore, if r is equal to -1 and the value of n is an odd number, the sum of the first n terms in a geometric sequence is equal to the first term. In the infinite geometric series, or S sub infinity, if the absolute value of r is greater than or equal to 1, the series is divergent and the sum does not exist. But if the absolute value of r is less than 1, the series is convergent and therefore has a sum, and obtained by the formula S sub infinity is equal to a sub 1 divided by 1 minus r. Let us find the sum of the terms in the following geometric sequence. First, S sub 7 of -7, 7, -7, 7, -7. From the given sequence, r is equal to -1, and n is an odd number. Therefore, S sub n is equal to the first term, which is equal to -7. Next is S sub 8 of -3/4, 3/4, -3/4, 3/4, and so on. Here, r is -1 and n is an even number. So the sum of the first n terms is equal to 0. S sub 8 therefore is equal to 0. Another example is S sub 6 of 7, 7, 7, 7. Here r is equal to 1 and n is equal to 6. A sub 1 is 7, so therefore we may use the formula S sub n is equal to n times a sub 1. So that is, the sum of the first 6 terms of the sequence is 6 times 7, which is equal to 42. For the fourth example, S sub infinity of the sequence 4, 12, 36, where r is equal to 3, and since the absolute value of 3 is greater than or equal to 1, the sum does not exist. Finally, we have s to the infinity of 8, 4, 2. r is equal to 1/2, and since the absolute value of 1/2 is less than 1, it has a sum. And we may use the formula s to the infinity is equal to a sub 1 divided by 1 minus r. Substitute the corresponding value of the variables. We have 8, which is the first term, divided by 1 minus r, and that is 1/2. So this is equal to 8 divided by 1/2, which is equal to 8 times the reciprocal of 1/2, that is 2/1. So the answer is 16. Therefore, the sum to the infinity of 8, 4, 2 is equal to 16. That's all for today. Enjoy solving!